Welcome to Carlton's Math Corner. Today we're going to be discussing functions. At this time, please make sure that you have your math journal as well as your vocabulary packet. Our target today is I can identify data and ordered pairs from a table. First of all, let's talk about functions again. Back in chapter 1, you were introduced to a function, and we talked about how a function is basically it's an equation. You plug one number in and we call those the input, and then you get one answer out, and that's called the output. And so one number is always equal to one answer, okay? And so this is like what a function looks like. It's a function machine. A function would be like y is equal to 2x plus 3. If I plug in 2, then what I do is I plug it in for x. And actually this is supposed to say plus 3. Whoops, let's go back. So let's change that to plus. There we go. So if I plug in a 2, this would be 2 times 2 plus 3. So 2 times 2 is 4, plus 3 is 7. And so the answer that spit out would be 7. So my input would be 2, and that's always an x coordinate because I'm plugging in for x. And then what I'm spitting out is a y coordinate, or my output. And so I have 2, 7. And so here's an example of a function, 3x plus 2. And so here's a table, and this is just for me to organize, my work. And in chapter 1, we filled out these tables so that we could plug in numbers and evaluate them. And so what I want you to notice is that when I plug in 2, well, and really I just chose these numbers to plug into my function. This is my actual function right here, 3x plus 2. It's kind of like my rule. What rule do I want, every number that I plug in, or all my x coordinates that I plug in, or my inputs, what do I want them, what rule do I want them to follow so that all of them are following the same thing? And that's kind of what a function is, you're plugging in an answer, a number within a rule, and they're following it, and then it's getting an answer that spits out. And so, and I don't know if you remember from chapter 1 what all of our x coordinates are called, but they are called a domain. And then how about all the y's that spit out? The range. Yeah, good. I'm so glad that you guys remember. Okay, and so we plugged in 2, and look what happens. 3 times 2 plus 2. The answer is 8. Now notice, basically you plugged in an x, you got out a y. That's an ordered pair. That's what the definition of an ordered pair is. So actually I can graph this down here below, and I'm going to do that so that I can, I want you to see what happens. If I plug in 2 and I spit out 8, 1, 2, 3, 4, 5, 6, 7, 8, I'm going to put a dot there. Then I'm going to actually change these numbers to make them a little bit smaller so that they don't go off our graph. So I'm going to change this to 0, 1, and I'm going to put a -1 in there, and let's see if we could do that one together. Okay, so remember we are using the same rule, 3, whoops, I'm going to actually take this rule, I'm going to copy and paste it so that it's the same thing. But I'm going to actually plug in 1 this time. And so 3 times 1 plus 2 is, instead of 8, what are we going to get? 5. Nice job. So if I plugged in, instead of 2, 8, what do we get this time? Well, we plugged in 1, we got an answer of 5. So 1, 5. And so let's plot that over 1, 1, 2, 3, 4, 5. Now let's do the next one. So if I plug in 0, well, 0 times anything is 0, so that would be 0, but then plus 2. So now I get an answer of 2. Nice job. And so my ordered pair is now not 1, 5. I plugged in now 0. Oops. 0, and I got an answer of 2. And so if I plot that, look what happens. 0, 1, 2. What do you notice is happening with these points? Yeah, they're all lying on a straight line. Now if I plug in -1, we're going to try this. Does anybody know, and even use a calculator, what is 3 times a -1? And if you didn't know this, it actually is just -3, because 1 times 3 is 3, and since there's only one negative, it's not enough to make it positive again. I need 2 to make a positive. And so I have -3, and think about it, if I'm -3 degrees cold, like if it's really cold outside, it's -3, and it warms up 2 degrees, where are you at? Exactly. We are at -1. Nice. So -3 plus 2 is -1. And so our coordinate is -1, -1. And so let's graph that. If I go over 1 and down 1, there it is. Now I want you to notice if I plot this point, I will get a line that is perfectly straight all the way through, and it's a straight diagonal line. This is actually what a function looks like. A function basically means that I can plug any of these numbers on the x-axis and automatically it spits out one answer. So look, I plugged in 0 on the x and I got a 2 out. I plugged in 1 and I got a 5 out. I plugged in a 2 and got a 8 out. If I plugged in 3, look at it, would spit out an answer. I would actually get a 10. Okay, and same thing over here. I plugged in a -1, I got a -1. Okay, so let's do another problem. This says use the graph to identify the ordered pairs for each problem. Well, here's my graph, this red line, and this is a function because if I look, I can go anywhere on this x-axis and I can plug in any of these numbers and I can get out an answer. So let's say I plug in 1. Well, look, draw a straight line up from 1 and look where it crosses that red line. It crosses at 2. So that means that if I plug in 1, I get an answer out of 2 and there's an ordered pair. How about if I plug in 2? What spits out? Well, if I draw a line straight up from 2, I hit 3. And so I get an answer of 3. So my ordered pair would be 2, 3. What if I plug in 3? Yeah, I get an answer out of 4. And if I plug in 5, what do you think would be my answer? 6. Yeah, nice guess. I can plug in any number. I can choose any. I can even put in some negatives. If I, plugged in -2, look where it hits. It hits at -1. And so that would be my answer, is -1. So if I plugged in -2, I would get an answer of -1. And so that's my ordered pair, is -2, -1. How about this graph? Same thing, let's identify the points. So if I plug in, let's go along the x. Okay. First of all, if I plug in -5, look where I hit. It actually lies right on the line. So that means that I would get 0. It didn't even move. What if I plugged in 1? What would I get? Well, that one's a tricky one because does it cross the line perfectly? Meaning, do you see these grid lines? Does it cross a whole square perfectly? No, it doesn't. So I really can't plug in 1 yet. I could plug in, is there another place where it crosses? Yeah, look at, it crosses at 5. So let's do 5. Okay, if I plug in 5, what do I get as an answer? Yep, I get an answer of 2. So 5, I get an answer of 2. Is there another place where it could cross? Well, it crosses actually at 0. Do you notice that? If I go straight up from the 0, I get an answer of 1. Now, I cannot really choose any of the numbers that lie halfway or a fraction in between some of these lines. I can't choose them because I don't know for sure what those numbers are. I can only choose numbers that lie perfectly on the grid lines so that I can actually give an ordered pair. Okay, let's look at our next target. It says I can graph data to demonstrate relationships and translate between graphs and tables. What would the table look like for this graph? So here's a graph, and this graph actually has a bunch of points on it. And graphs in general, any kind of line that I graph actually has an infinite number of points. I can choose any point. But this graph actually has some points chosen for us. Now remember, the x-axis down here are the numbers you plug in. Those are called our inputs, or input or domain. And then the answers that are spit out is the y-axis, and that's called our range. And so if I wanted you to set up a table just by looking at this graph, it's kind of like what we just did. We look at the x's and notice at +2, look what happened. I plug in +2, look what answer spit out. 1. And so I would put 2 and 1. How about on this? What if I plug in 3? What do I get? -1. Nice job. What if I plug in 0? What do you get? 5. What if I plug in, how about -1? Well, if I plug in -1, look what happens. It hits right there, which is 7. And so my answer is 7. And so I'm creating a table just by looking at this line. And literally, I can choose any points on this line as long as they lie perfectly on a grid line. Those are the ones that I want to put into my table. How about this one? If I wanted to, let's say, plug in 4, what would my answer be? Well, if I plug in 4, I spit out 3. Nice job. What if I put in -2? What would my answer be? 0. Good, because it really doesn't move. Do you notice that? If I plug in -2, it stays right there on the line. And so that would be my answer. What if, last one, if I plugged in -4, because you guys are really good at this, if I plug in -4, look where it crosses. -1. And so I would type in -1 as an answer. Perfect. What if I asked you, does this graph and this line match? Are they the same? How could you check? Well, you could actually go along the x-axis and kind of choose some points. So for instance, if I choose, let's say 3, well, where does it cross on 3? Well, it crosses this blue line at 1, 2, 3, 4, 5, 6, 7. It crosses at 7. So that means I should have an ordered pair somewhere of 3, 7. Yeah, but look at this table though. Does it say 3, 7?